Product of electrolysis depends on nature of electrolyte, that is molten or fused. Second one is aqueous solution. Concentration of electrolyte, concentrated, and another one is diluted. Nature of electrode: one, inert electrode, that is platinum, gold, graphite. Second one, active electrodes, that may be zinc, copper, silver, iron, etc. Other than these three, platinum, gold, graphite, remaining are active electrodes. Standard reduction potential value also affect the product of electrolysis. At anode, lower SRP value, standard reduction potential value, element first discharge, example F minus, Cl minus, Br minus, I minus. I minus value, standard reduction potential value, lower than the bromine, and bromine value is lower than the chlorine, and chlorine value lower than the fluorine. So this is a discharge order. This is called discharge order. At cathode, higher SRP value element first discharge, example gold plus 3, Ag plus, Cu plus 2, H plus, Pb plus 2, Sn plus 2, nickel plus 2, Fe plus 2, Al plus 3, sodium plus, lithium plus. These are according to SRP value, higher value to lower value, but this is a discharge order. Which is first discharge? Gold first discharge. Least which is discharge, meaning last, that is lithium plus. Example 1, molten NaCl. First step, what we have to do, write the ionization step. NaCl ionize into Na plus Cl minus. This is called ionization step. Next step, second one, you have to write reaction at anode. So at anode, what is the charge? Positive. Therefore, which ion will be discharged here? Negatively charged. Positive attract the negative. Therefore, negatively charged ion is Cl minus, that will be converted into Cl2 plus electron. 2 chlorine, therefore 2 times multiply, then 2 electron. This is called oxidation. This is called oxidation. Then third one step, you have to write reaction at cathode. At cathode, what is the charge? Negative. Then now which ion will attract here? Positively charged ion. So that is Na plus sodium plus charge. This will be gain electron, convert into sodium. Then how many electron loss here? 2. Therefore 2 electron will be gained. Therefore multiply with the 2, then multiply with the 2. This is gain of electron is called reduction. Gain of electron is called reduction. So what is the product at anode? Product at anode is Cl2. Product at cathode is sodium. These are the product at anode and cathode. Now, according to this, their reduction potential value, sodium value is nearly minus 2.71 volt, and this is the reduction potential value I am writing, and chlorine is 1.36 volt. So now if you write, then we know that E cell is equal to RHS minus LHS. This is RHS, this is LHS. Therefore, minus 2.71 minus 1.36 volt. This is nearly minus 4 point something. Okay, 6 plus 1, that is a 7. 7 plus 3, that is a 10, and 2 plus 1, 3 plus 1, that is 4. 4.7, 0.07 volt. Minus means this is a non-spontaneous. What do you call this? Is a non-spontaneous reaction, because we are supplying the electrical energy source, then a chemical reaction takes place. This is the product of electrolysis of molten NaCl. Similarly, I will take the another example, magnesium chloride molten form. Then first step, what is that? Ionization step. Then MgCl2 ionize into Mg plus 2 plus 2Cl minus. Second step, at anode. At anode, what is the charge? Positive. Then this Cl minus will be converted into Cl2 plus 2 electron, 2 Cl minus. Similarly, same you can write here 1.36 volt reduction potential value. Which one? Always we are taking which one? Reduction potential value. Reduction potential value this is. And third one step is at cathode negative charge. Then here Mg plus 2, take the 2 electron and convert into which one? Mg. Then here its reduction potential value is minus 2.36 volt. This is also reduction potential value, E naught reduction potential value. You can write here always, you will get which one charge here? E naught cell, that is negative. Negative you are getting meaning that is non-spontaneous. Now the question is, what is the product at anode? Cl2. What is the product at cathode? Mg. Like this, any question asked based on the molten, there is no competition between the ions, because only one negative charge, one positive charge form. Therefore, there is no competition, then writing product is easy. Similarly, we will take another example. That one is third one example, molten AlCl3. Molten AlCl3, first step is ionization. AlCl3 ionized into Al plus 3 plus 3Cl minus. Second step is at anode. Anode, what is the charge? Positive. Therefore, Cl minus convert into Cl2. Now, NaCl aqueous solution by using inert electrodes. The first step always we have to follow, that is ionization. NaCl aqueous ionize into Na plus aqueous plus Cl minus aqueous. Then in this water molecule also present, that will be ionized into H plus plus OH minus. This water is weak electrolyte, therefore degree of ionization is very less. That you have to keep in mind. Now second step, reaction at anode. At anode, what is the charge? Positive. At positively charged electrode, negatively charged ion will be discharged. That is Cl minus OH minus. OH minus actually from water. Now I am writing the product at anode. Cl minus convert into Cl2, then plus 2 electron, then here 2. We know electrode potential value. These are standard reduction potential value 1.36 volt. Then here OH minus is there. OH minus actually very small amount. Therefore water will be participated here. Then H2O convert into O2 plus H plus electron. Here two oxygens are present. Therefore multiply with the 2 oxygen. 2 into 2 4, then 4 hydrogen. 4 plus therefore 4 electron. Total balanced equation. its value reduction potential 1.23 volt. So already we know that at anode lower reduction potential value required. Therefore, which one will be undergo oxidation? 1.23 volt. But actually, according to values, oxygen will be the product. But this is not reason. I will tell you. First, the product formed at anode is Cl2. That is due to over potential. Why this is a product? Reason because of over potential. Over potential of oxygen. So whatever the potential applied, at that potential oxygen not liberate extra potential required to liberate the oxygen gas, that is called over potential. Therefore, due to over potential of oxygen, which is a product here, chlorine. So you have to remember, when chlorine oxygen is present, then oxygen is not liberated, chlorine only liberated at anode due to over potential of oxygen. So to liberate oxygen, extra potential required. That is called extra over potential or extra potential. Now second one completed. Third step, at cathode. At cathode, what is the charge? Negative. So negative in which ion will come? Positively charged Na plus and H plus. H plus ionization is very small amount, therefore water only reduce here. Now Na plus, it takes the electron from the anode, that is 2, therefore 2, and convert into 2Na. Its E naught value we know that minus 2.71 volt. In case water also is there, then water takes the electron and convert into H2 plus OH minus. Left side 2 electron, 2 minus here, then 2 oxygen, then here also 2, 2 into 2, 4 hydrogen, 2 hydrogen, 2 hydrogen, 4, balanced. Its reduction potential value minus 0.83 volt. But you can write like this also, H plus plus 2 electron and 2H plus convert into H2. Then this is electrode potential 0.00 volt. But this is very small amount, therefore preferentially which one we are writing? H2O. Now the question is, here value is minus 0.83, here value is minus 2.71. Higher value reduce at cathode, so this is a higher value, therefore this will be the product. It means hydrogen gas is the product at cathode and chlorine gas is the product at anode. All together, overall, if you want to write, then what we can write now? At anode, A means anode consider, that is positive charge,